Hi, and welcome to the first repair video in English. A lot of people have asked me to do this with us in English, and I said that I couldn't do it because most of my customers are from Sweden, so making the videos in Swedish was the most natural way to make them. But I'll make an exception this time to see how it goes. Today I have this nice box with a it's too high. This is a power supply for a cattle feeding, which is broken. I have had it for about 2 weeks and checked most of the components, and nothing's burned or anything. So my primary suspect was a MOSFET, switching MOSFET, but it wasn't. It's working properly. So there was something else, which I think was the PWM controller or feedback network or something. So this board, we have mains 1 volt, 230 volts. We have a rectifying bridge. The whole this side is a primary input. Let's check the back side. Here, the manufacturer has delimited the circuit board. So here is a primary side where the main small voltage comes in. Here's the secondary side where the secondary voltage comes out. It's supposed to be 24 volts at 4.5 amperes, but right now it's 0 volts and 0 amps. So far I have checked the MOSFET, I've checked the regulation on the primary side. Everything works as it should. All the voltages, that's a hard word, voltages, volts, all the volts are here, up to this point somewhere. Here is a PWM controller, and that is an optocoupler. My hypothesis today is that one of these two guys are broken, maybe both of them. So I purchased a spare part, and today I'm going to replace these two ICs. It's an 18 dip and a 6-pin dip. So let's see how it goes. I will remove this and lower the camera for a better view. Like that, yes. So at first I will be powering up my desoldering station. Look like that. It will take a while, about 2 minutes. It's an older, slow one, but it's effective. 400 degrees Celsius will be too high, so I'll lower it to 350. For the soldering, I use that machine as well as I have no idea what this is called in English. Tongs. Grappler, I have no idea. This thingy. I'm using this thingy. Maybe a screwdriver or some other kind of extractor. And see now, this screw is not supposed to be here, so I'll put it aside. We have spare part 1 and spare part 2 arrived in the mail today. The solder station is up to 240. Let's see, the 8 dip, and this should be the 6 dip. Yeah, this is the optocoupler, and this is the PWM controller. But first I'm going to make a marking on the circuit board, because... Ah, okay, it was marked. It was marked. Because it's entirely possible to reverse the chips and make things worse. I don't want to do that. $350, okay. I will desolder right now. It's a fancy equipment. It's basically a soldering iron with a vacuum pump. When I press the button here, it sucks in. Instead of using this, I could have used a normal soldering iron and a manual vacuum pump. These two combined make this. This is way better. The machine is quite noisy, the fan is very noisy, so I'm not sure you can hear anything that I'm speaking while I work. So I will just remove all solder, speak later. I will not speak during the work. Now, if you can see that, these 6 pins here, I removed the solder. I will turn on the board and see if I can put a screwdriver under the chip. Yeah, it goes off smoothly. I'll just put it away and go to the next chip. I see now under the IC, oh sorry, under the IC is a nice pictorial, or whatever you call it. So I will not put the chip in the wrong side. In the wrong seating, location, rotation, something. You get the idea. 8 more pins. Okay. There's a big area with a ground plane here. So I will have to increase the temperature to 400. And I will cheat. I'm gonna put the syringe. Where's the syringe? Ah, here. I'll use some flux. I hope that helps. Let's put some flux on the board. The purpose of the flux is to reduce the melting point of the solder and also remove any sort of impurities. The impurities need to be gone when you solder components on the board, but when you desolder, the impurities is not a problem. But lowering the melting point for the solder is a big issue. So you want it as low as possible. Okay, I will have to turn on the solder station half. One pin left. That is on a ground plane, and this gun wasn't able to remove it, so I will combine my solder station with my desolder station. If you can't solve one problems, you have to get creative, and then you will be able to fix the problem. So preheat with the solder station, jump into it with a desolder station. There you go. Now we'll just check if the chip will drop out. Yeah, easy peasy. I'll turn off this noise-making maniac so I can think again. I'm not sure the microphone picks up all the noise, but this machine and its fan, it's horrible. Really horrible. I have pliers. Ah, that's the word. Pliers. Not tongs. Pliers. Pliers. And the dip bait. Won't budge. I use big pliers. Yeah, there it is. Dip 8. Dual inline package. I think that's an abbreviation with dip 8. 8 pins. And as we can see below the chip, there's a tutorial there as well. Now I got thermal grease on my fingers, and it's really greasy. But that's life. So here's the dip 8. I need to double check the marking of the old one because I'm not sure it's the same. I'll check the after coupler too. So the new one is called SG3843. The old one is called SG3843. Yeah, it's the same one. The old optocoupler, CNX82 was a new package. The new package, where are you? You're kidding me. Oh, great. I forgot to clean my desk before starting this job, and that's a big no-no. Always use a clean desk. Always. Always, always, always use a clean desk. The package is on the floor. It's encased in bubble wrap plastic and tape. So just rip it open. Throw that away. And even more tape. Why? Oh, the new one is called CNX82A, the old one is called CNX82A. It's the correct one. So I'll start with the dip 6, the optocoupler. Put it in the hose. And it's a tricky one, because the legs are wider than the hose. Almost spread. There you go. Pin 1 is correct. More grease on the fingers. There's pin 2. Oh, sorry, I see 2. Pliers. Okay, this is what's the trick one. There you go. A grit. Let's get belt. Back up and try again. Always try again. Never ever give up. There you go, buddy. So I'll put some solder, but a half millimeter. I want the 1 millimeter. There it is. Just solder 1 pin in both chips. And the reason for that is I want to make sure both are seated correctly. If it was not, so I'm putting my fingers on it, reheating the solder. There, it fits nice. Do the same for the dip 6. Perfect. Now, both are seated correctly, so I will solder all the remaining pins. It's a single-sided board, so it's fairly simple to repair. But it's always... Oh great, shorter too late. As always, the most complex part of repairing is finding the root cause for the particular problem. That's the most time-consuming part of my job, finding the source of the error. For this board, I'm not sure these two are the culprits, but that's right now the only thing I can think of. That's what this job is as well. Sometimes you have to wing it. There's no other way, because these boards comes with 0 documentation. I never have a schematic, I never have a documentation, any guide, anything. It's 100% guesswork. Sometimes guesses aren't good enough, but that's life. I inform all my customers that I may or may not be able to repair this. that's what I say for this board. Some boards, the errors are clearly seen. For example, if there's been a fire or something, a short circuit that ended in a fire. But this board was not obvious. So this board, I'm just winging it. I'm hoping my hypothesis is correct. I will get my answer after our solder is due, and I will test run the board, plug it into the main socket, and measure the output. If I'm correct, if my winged method was correct, I will see 24 volts on the output. If not, I can't do anything more. The customer is aware of it. He's aware of the risk that it might not work. He's gambling as well as I am. So, short of 2 pins, I will use manual soldering, solder pump or working pump or something like that. I'm not sure of the name of it, but it works. Okay, my solder station says SE. Why? It's cold. Are you kidding me right now? I think the solder station is telling me that the heating element has broken down. Okay? That means basically I can solder using this. So I'm trying to power cycle it, see what happens. On, power 350 SE. Okay. So it's failing me. It's first time in 4 years. It's a very reliable solder station. At an 8502. Plan B. Always have a backup. Always. Because you never know when the tools will fail you. Like they did right now. I have a new heating element for the solder station, but it will take some time to replace it, and I will not do it right now. Instead I will use my backup solder station. This one has never failed me for 15 years. This one is very reliable. I will just plug it in. Move the microphone cable. There's a cable sucker. Please don't fail me now, after 15 years. Are you fucking kidding me? You are kidding me. Or you can connect the solder iron. Because a double failure on the same night, no. Very unlikely. Please work. Thank you, heating. Where's my water? Here's my water. This solder section is pretty old. Let me change camera. It's pretty old, so it takes some while to heat. A lot of people have asked me how to do I have no idea what it's called in English. How to do how to find the errors, how to find the bad components, how to make a proper error searching. No, that's not the word. Felsökning in Swedish. Bug hunting in coding language. No, how to find the errors, how to spot the errors. What's the method for? Because I don't have any schematics, I don't have any documentation, so where do I start? How do I find the errors, etc., etc. There is no universal answer to that question. It's a complex answer because it all depends. It depends, but depends on what? Depends on the kind of error. What kind of error is it? Of the burn marks, can you find soot? Can you find ashes? Can you find exploded components? Or does the board look okay? Look brand new, but still doesn't work? It all depends. This board, for example, when I got it, the owner said doesn't work. That's the only, that's the sole error description I got. Doesn't work. Which means I had no idea what was wrong. Some boards have indicator of some sorts. For example, light emitting diode to tell the user that something's working. For example, a power lamp or status activity or something like that. This board has 0. It doesn't give me any ideas or hints or anything what could be wrong. So for this board, I had to do the tedious work of, so to speak, tracing the mains voltage up to the point where the voltage doesn't exist. I'm not sure that's comprehensible, but basically the first clue for this board was that, you see it? No. These 3 screws are labeled AC/L, as in line, the hot line. The next one is AC/M, the neutral line. And the third one is a PE marker. PE means protective earth. That's a ground cable. That's the first clue. I know where to put the mains. So let's say these markings were not here. How would I know these screws are from mains? This fuse, can you see it? No, of course not. This fuse is a dead giveaway. Fuses are always near the AC input. Also, there's always, not always, but very often, a very big capacitor, filter capacitor. I think this is an X2. The line filters, removes noise from the line, from the AC line, as well as a big coil inductor. That's a dead giveaway for an AC input. Here we have a bridge rectifier. There's a switch for 230 or 120 volts. big capacitors for rectified voltage, and then the magic here. So you have to start at the for board with this kind of problem. It doesn't work and has no kind of indication. You have to start at 0 and slowly walk the trail, so to speak, to see where the voltage stops. If it doesn't work, there's always at least one point where the voltage stops, just disappears. Or in other words, it doesn't appear. The primary mechanism for an SMPS switch mode power supply, like this one, is you have a primary AC input. You go through a few stages where it gets rectified, filtered, chopped up into high voltage DC, then fed into a PWM controller and maybe some optocoupler like this and a feedback network. Then it's pushed to a very large high frequency transformer like this one. So what I did for this board was to find out the AC input, then I measured the primary input, the primary side pins for the high frequency transformer to see if there's any activity. Was there any voltage? The answer for this board was no. That means if there's no voltage here, there will be 0 voltage in the output. So somewhere between the AC input and the transformer, the voltage goes away. In this case, here's a MOSFET, the chopper, the high frequency, reflection, like this. Here's a chopper, high capacity MOSFET. There's no voltage, and the voltage at the MOSFET, that's where the actual switching comes in, where the actual switching starts. If there's no voltage at the switcher, there will be absolutely no voltage at the transformer. So why does the voltage not reach the chopper? It's a rhetorical question, because I don't know the answer. Somewhere between the primary AC input and the chopper, the voltage got lost. Unfortunately, I do not have a schematic for an SMPS, not even a general one, so you will have to Google it. But if you Google SMPS, the letters SMPS, Simon, Mr. Peter, Simon, you can find a schematic, and you will see that the MOSFET is connected to a delicate network called the feedback network. There's a lot of resistors, capacitors, maybe not capacitors, but resistors at least, and a PWM switch, and maybe an optocoupler. It's a mishmash of connections, mishmash of components. And if that feedback network doesn't work, the chopper won't either. They rely on each other. I forgot the point of all this. Yeah, it started by some people asked me how I found the errors. Yeah, this is one way to find the errors. find the point where the voltage stops and go backwards or forwards. Generally speaking, it's not a simple solution, simple one-fix-it-all solution for all boards. This method will not work, for example, in a CD player or something, or similar, because they're not of the same type. You have to adapt the method depending on what kind of board it is, what kind of error it is, what kind of anything. You have to broaden. That's why, no, not that's why, but that's how I work. Most people, most repair shops work. In Sweden we have a saying to jobba inom ramar. I'm not sure how to translate that into English, but ramar is a frame, picture frame. That's a ram. And when you jobbar inom ramen, you work inside this frame. You never go outside. Thinking outside the box. That's the proverb I'm searching. I think I work outside the box. I'm never inside the box, because inside the box it's dull, it's boring, it's repetitive, tedious, monotonous tasks. It's boring. I hate boring. I love challenges. I want really fast clacking challenges, so that bumps my brain. My brain loves challenges. Always think outside the box. Always. Never rely on one single technique. Adapt. Learn many techniques. Combine. That's the only way. If you have a schematics, it's a whole different story. It's easy. Without schematics, it's hard. Really hard. But that's what I thrive in. So, soldering iron, sorry for the blabbering. Soldering iron is done. I will remove the short circuit. Switch the camera. I think I can remove this one. Raise it gun. To get a better view. Yeah, that might work. Sorry if it doesn't. Let's see. Clean the tip. Yeah. Where's my solder sucker? Behind. Ah, that's another one. So, heating both pins, solder suction both, and apply. Where's my solder? Let me repeat rule number 1. Use a clean desk when you're working. I did not clean my desk before I did this work. I have no idea why. Because a messy desk is okay if it gets messy while you're working. But if it starts messy, everything will be messy. Like this. But let's see. Okay, not a very good zoom on this one. I think I shorted again. I'm not sure. I'm not sure there was supposed to be. Are you kidding me? Now this tool is failing me. Thank you. Okay, there's a solder base. There's supposed to be a short circuit. Shorted. For short. 6 pins. It's done. Number 8 pin. Pin 1. No, sorry. 2. 3. Near the ground plane. Yeah, work nice. Yeah. Okay. I'll turn the solder iron off. Now I will double check my soldering so I do not have a short anywhere. That's the thing with power supplies. You really have to double, triple check the soldering. Because if you screw up on here, any kind of damage might happen. Like for example, check here. There's a large spot of something just sitting on the board. If it wasn't here, it's from the solder cycle. If it wasn't here when I powered it up, it was right on the transform as well, meaning about 350 volts DC would get shorted here. That would mean game over to this board. Double check the solder, check it, pin 1, 2, 3, okay, there's some flux residue, remove it, scrape it, pin 4, 5, 6, okay, small flux residue, just remove it. Dip 8, there's a shorting piece of metal, 1, 2, 3, 4. There's a small solder block between the pins. Very, very dangerous. Looks okay. Okay. There's a potential problem here now, I see. The computer with the cameras is hooked up to the testing socket, which I normally use for testing. I have an extra fuse on it. This one. This is my on and off switch for testing mains thing. It goes up to these two. And the computer is connected to the top one, which means I cannot use the fuse as a power on, power off button. Which means the power will be on for this board as soon as I plug the cable in. Which is fine, but I need to keep that in my mind. Usually I have a special made cable with a switch on, together with that fuse. Because when it comes to mains voltage, you can never be too careful. Never ever. Because mains voltage can kill you in an instant. It's no voltage you are supposed to play with. That shit is dangerous. For real. True story. Fuse is okay. Switch is set to 230. MOSFET is okay. These are soldered okay. The output comes here. Ah, nice. I'm already time for the marker. Plus on these ones, minus on these ones. So I do not have to turn and switch and stuff. So I'll just plug in my nifty safety thingy here. Great. Do. I need to solve this somehow. Remove the microphone. That's an idea. That won't work. I will make a new connector. This one. We'll cut down and use wires here. Maybe it's a waste of cables, but I have about 40 of these in the box. Okay. I'll grade some tape. A sticker or whatever it is. Just go away. I do not want you. Let's do it like this. Cut the cable, not good. Cut the insulation, so I will have to cut it. Great. Need to be more careful. There. If you accidentally cut a small cut in the insulation of a cable, do not use it, please. Just don't. Strip the wires here. Clean those wires. Protective earth. Line and neutral. The screwdriver, where's my screwdriver? see, L to the left. Neutral in the middle. PE to the right. There. Now, what? As soon as we plug the cable in, this will be powered on. So I need to take it through here. I need to measure the output. I will do that with my trusted old friend, Fluke 179. I can reuse the cables here, like this. I'll put the brown one in plus, the blue one in minus, and connect an alligator clip to the brown is plus, blue is minus. See, I have an alligator clip here somewhere. There's a black one and red one. Red to brown, black to blue. Let me see here. I'll put the Fluke here. Maybe I can stand it up. Yeah. No, I will put it down. You can see the number on the camera. Yeah. So take the red alligator cable and connect it to the red probe. Let's do like this. On the back of the multimeter, back of the Fluke, there are two probe holes. I put them here. Just clip all the lead to the probe. There you go. The black one to the black one. Then remove the cables. Let's see, no metals. Yeah. Begun metals. So here's the deal. Moment of truth. What I'll do now is to plug the cable into the socket. And if I'm correct, if I was right on this board, it will show somewhere around 24 volts DC. If it doesn't, there are two outcomes. Outcome 1, it would be 0 volts, which means I was wrong. It would be 3 outcomes. Sorry. Outcome 1, 0 voltage, I was dead wrong. I'm a bad person. Kind of wrong. Second outcome, 24 volts, I was right. Third, something else other than 0 or 24, which means it works better than before. It means something else other than the optocoupler and the PWM circuit was wrong. You see, everything is hooked in. Worst case scenario, something starts to burn. There will be an explosion or something. I hope not. Let's see. I have taken the safety precautions I can. So now I will hook it up, hook it in, put it in, whatever. Red to brown, black to blue, mains is powered correctly. Okay. We'll find the socket. I will plug it in. Oh great, that's some scrap in here. 1, 2, 3. 0 volts. I was wrong. I was wrong. No! What happened there? Hey, some activity. What happened? It went up to, I didn't see it. 20 volts? I don't know. I remove the cable. Now, here's a problem. Here's a problem. When I unplug the power cable, the big capacitors on the AC line are still charged. I'll show you. I know where they are because I measured them before. They're charged with a very high DC. Let's see here. Here's a minus and that's plus. I don't know high or high, but it's going to be very high. Okay, it dropped very fast. Okay, that's good. I will plug the cable in and I will show you how high the walls really are. Because now it's plugged in, now it's live, now it's dangerous. Now it's real dangerous in the first area here. There's a line here that shows that this is a secondary area, which is a lesser voltage, but the primary area is real dangerous. I'm just trying to not obscure the view. Let me see here, but I do not want to short circuit. There's minus, there's a plus. 155 volts DC. It should be the double. Ah, okay. Minus here, plus here. 160. Okay, this doesn't make sense at all. Okay. It's supposed to be over 300. But it's not. That's a new symptom. Okay, I'll measure the rectifier. These 4 pins straight in here. So minus goes here, plus goes here. There you go. 370 volts. This is a very high DC voltage. I'm not sure you can see it, but next to the 3 on the fluke, there's a flash, there's an arrow, meaning that voltage can kill you instantly. Just because it's DC doesn't mean it's not dangerous. Quite the opposite. So, okay, when one is new symptom, the capacitors are supposed to be 315 volts or whatever. Let's check it again. Ah, now we have that. Okay, okay. And a single capacitor should be 162. Yeah, that's correct. Okay. There's nothing new symptom. The thing with sorry, the thing with these primary side main capacitors is, not for this board, but most power supplies in general, they will contain the lightning charge. They will contain the charge for a long time, even when you pull the plug. This board somehow drains the energy, drains the charge very quickly. I pulled the plug and 10 seconds later I measured there was about 2 volts or something. But most boards don't do that, meaning the 300 volts over the capacitor will be contained for a few minutes maybe. It will degrade with time, but very slow. So for those boards, when you pull the plug and accidentally put a finger on it, you will be harmed. It will hurt badly, really badly. That's why you have to be really careful with these kinds of power supplies. Really careful. Double, triple check everything. Safety, always. Never ignore safety precautions for S&PS. Cable is still plugged in. And check the output. This is still dead. Why? Why? This sucks, really. I spent an hour making this video and I failed. That's kind of an irony. I was supposed to make my first video in English and succeed, but now I feel like a failure. That's a dull sound of my job, of any job really. You can't always have the ups. You need to have the downs as well. Because after all, we are just human. But it sucks. Really, it sucks. I will unplug the cable. And I will measure. I put the measure probe on here right now. You see, it's falling rapidly. It's still high, but it's falling. Other boards will fall way slower. It's 40 volts going down to 30. After 30, the arrow there, the arrow is gone. Now it's not dangerous. Goes down steady. Okay, I am truly sorry I couldn't fix this. told the customer, as I said before, I cannot guarantee anything for this board because it's not obvious what was wrong. He took the gamble as well as me. These kind of boards show up every now and then. They're broken, they show no signs of any errors or anything. It just simply doesn't work. Unfortunately, this one is one of them. The simple solution here, or the light side, or the bright side, is that, sure, this is a power supply for a car feeder. That's 20, 30 years old or something. This power supply does not exist as a spare part manufactured at the manufacturer, but there are other kind of spare parts. No, there are other kind of power supplies which you can purchase and give to the customer. The only thing they have to be able to produce is 24 volts at, as I said earlier, 4.5 amp. So this one is pretty, how to put it, a simple power supply. A more complex power supply would have, for example, 24 volts, 12 volts, minus 12 volts, 5 volts, minus 5 volts, etc., etc. But this one has a fixed output voltage rated for 4.5 amps. So it's simple to replace it with another one. And that's what we have to do here. Because I cannot find the error. I'm just human. But this board will bug me for sure. It will show up in my dreams and everything and laugh at me and etc., etc. But I can't do anything. So, to conclude, this was my first video in English. If it turns out to be working, if anyone can understand what I'm saying, I might be able to continue producing them with working repairs, hopefully. But this was the first one. You have to try. English is my second language, so it's good practice for me as well. So we'll see how it turns out. Now I will wrap this up and put it back into the box, and tomorrow I will call the customer and tell him that it doesn't work, so I will find a power supply that matches this one. So I will just switch it, replace it. The clock is 22. So it's time to wrap things up in my workshop and go to bed. So I'll say thank you and good night.